what is our gradient? 3 over 4. What is our x? Our x is minus 2 plus c. So I'm interested in looking for my constant. Then I will have 3. This time this is minus 6 over 4 plus c. Then 2 can divide it. 2 here 2, 2 here 3. So I have 3 minus 3 over 2 plus c. So definitely this one will be, to get my c here, it will be, I will transfer this on the other side. I have 3 plus 3 over 2 over 1. What's this? 2 as the LCM. 2 times 3, 6 plus 1. That's 9 over 2. That would definitely be 9 over 2. So my C is equals to what? 9 over 2. So let me go back to my original equation of line. Y equals to mx plus c. So what is my y? I don't know what y is. But I know that this one is 3 over 4 x plus 9 over 2. Because my intercept is c is 9 over 2. My gradient is 3 over 4. So I have this because I substitute. Y remains the same. Gradient is 3 over 4. That's what you have. X remains the same. Then c is what I've calculated here. So what's the LCM here? LCM here is what? 4. So I multiply 2 by 4. Multiply y by 4, 4y. Multiply 3 over 4x by 4. That will be 3x. Multiply 9 over 2 by 4. That will be 18. So here, to now get the equation of my line, I will transfer everything to the other side. I have 4y minus 3x minus 18 equals to 0. So this will be the equation of the line. Now, the question 9, I have this as my answer. Though, based on the way it is structured here, the answer is not evident here. But I can restructure this to suit the option there. What do you have? Minus 3x plus 4y minus 18 equals to 0. Then let me transfer this to the other side. I have 3x. Transfer this to the other side. I have minus 4y. Then transfer this plus 18 equals to 0. So let's see whether this option is there in the option. Here we have 3x minus 4y plus 18. So automatically it's option A. You can see how JAMB can be so, or UTME can be so tricky. So I got this. Meanwhile, I couldn't find this in the option, assuming that there is no preferred option. But by the time I restructure, that is why it is good to restructure. So when I restructure this and I have this format, and I can see that it is evident that A is my option. So one has to be very careful when handling questions of this kind. Then question 10, the distance between the points 4,3 and intersection, and the intersection of this and this is. So you know that this question is testing two things. It's testing distance between 2 points, which we all know. There is also testing intersection. When you have intersection, that means they are equal. So distance between 2 points, the formula is square root of x2 minus x1 all squared plus y2 minus y1 all squared. That's the formula. So we cannot just bump into this directly. We need to find out what those points are, because at this point we are given the first point, but we can't determine the second one until we have resolved this. This one you have y equals to 2x plus 4. Then I also have y equals to 7 minus x. So since y equals to this and y equals to this, I can equate this. 2x plus 4 equals to 7 minus x. So let me collect, I have 2x plus x, collect like terms, 7 minus 4. So this is 3x equals to what? 3. Then divide both sides by 2. So I have my x to be equals to 1. So when equals to x equals to 1, let me now determine the value of my y using any one of the two equations. Let me use this. Y equals to what? 7 minus x. When x equals 1, so y will definitely be equals to 7 minus 1. And my y will be equals to what? That is 6. So I have 1, 6 as the second point. Then, to now resolve to resolve into distance between 2 points, which I know. Distance between 2 points will definitely be x2. Where is the first point? The first point is given in the question, and that is 4,3. 4,3. So I have x1, y1, x2, y2. So x2 has 1 minus x1, 4, all squared, plus y2, 6, minus y1, 3, all squared. So d will now be, this one will be minus 3 squared plus 3 squared. So what's minus 3 squared? That is 9, plus 3 squared, another 9, that's 18. That's 2 times 9. So what is the square root of 3? Of 9, that's 3. That will be 3 root 2. So it's going to be 3 root 2. So go to our option and see the one that matches that, and that's option B. Question 11. That is, find the equation of the line through the points. So we are given 2 points, and the question asks us to determine the equation of the line. So we have minus 2, 1. We have minus half, 4. So in this situation, let's quickly identify our coordinates. x1, x2, y1, y2. So what is the formula for calculating or for finding the equation of the line? But this time around, we have 2 formulae for finding the equation of the line. The first one is when 1 point is given. But in this regard, we have 2 points. So we have to use the gradient, which is y minus y1 over x minus x1 equals to y2 minus y1 over x2 minus x1. So in this situation, then what is our y1? Our y1 is 1 over x minus, what is our x2? Minus 2 equals to y2, 4 minus y1 minus 1 over x2 minus half minus x1 minus 2. So this one will be y minus 1 x plus 2 minus times minus plus equals to this minus this 3 minus half plus 2. So this one will be y minus 1 over x plus 2. And this one will be 3 over minus half plus 2, that is 1 and a half, which is y minus 1 over x plus 2 equals to 3 over, this time this, that's 1, 3 over 2. 3 over 2. So y minus 1 over x plus 2 equals to 3 divided by 3 over 2, which is y minus 1 over x plus 2 equals to 3 times 2 over 3. 3 here 1, 3 here 1. So I have y minus 1 over x plus 2 to be equals to 2. And I cross multiply. I cross multiply is y minus 1 equals to 2 into x plus 2. And it's y minus 1 equals to 2x plus 2, x plus 4. Is 2x plus 4 then. Collect like terms. Y equals to 2x plus 4 plus 1. And y equals to 2x plus 5. So y equals to 2x plus 5 is the equation of the line. So we go to our option and see the one that matches that, and that is option B. Question 12 of figure 1.6a. The angle between the positive horizontal axis and a given line is 135 degrees. Find the equation of the line if it passes through the point 2, 3. So in this situation, we know from our residual knowledge, we know that if you have a line like this, and you have it, a line is perpendicular to it this way. So automatically, if it's going to move in that region, so you have, this is your 90, and we are talking about 135, so it will be it is exceeded a bit. So such that you could even have a scenario like this. You could have a scenario like this whereby you have it moving like this, 90 and 135. Then if you check this very well, you discover that this is your first quadrant, this is your second quadrant, this is your third quadrant, and this is your fourth quadrant. So here you have 90 here, so it's moving somewhere around here. that is making it 135. So the whole of the distance from the angle from this place to this place is going to be 135 degrees. And remember that only tan is positive here. So in this situation, since you are having in this region, automatically you have 135 minus 90 will be this angle between this place and this place. And that's 135 minus 90 will give us 45 degrees. So in that situation, we have 45 degrees. And remember that the formula to solve this particular problem will definitely be the equation of the line will be x minus y minus y1 over x minus x1 equals to negative of the gradient. And our m is tan theta. In this respect, our m will definitely be, it will be, our minus m will now be minus tan theta. And since our theta here is 45 degrees, so automatically it will be equals to what? Minus tan 45 degrees. And by special angle, tan 45 degrees is 1, using special angle. Then, since our tan 45 degrees is 1, so we can go back to here and say then minus m, which is there, minus tan 45 will now be minus m, which is your gradient, will now be minus 1. So in that situation, then we can come back to this, our original equation, which is the equation of the line. So in this situation, we're going to have y minus y1. So we go to our point. Where is our